Welcome to my presentation. This presentation is part of the playlist Indefinite Integrals. In this presentation, we will be solving problems using the rules of integration. Let's look at some example problems using the sum rule of integration. Let us say we have an example of this kind. Y is equal to integral x plus 3 dx. So since there are two functions in here, and function which has an x involved in it and a constant term involved in it. So in this case, we're going to integrate each one of these functions separately as shown here. Integral x dx plus integral 3 dx. And once we have it in this form, we can use the power rule to integrate the first part of this problem, and we can use the constant rule to integrate the second part of the problem. When we use the power rule, integral x dx, since x means x to the power of 1, the ones are implied, so we can use the power rule for this part of the problem, integral x dx. When we integrate that, it is going to be x to the power of 1 plus 1, the whole thing divided by 1 plus 1, plus c1, which is a constant with respect to this integral, plus integral 3 dx. 3 is a constant, so we're going to take it outside of the integral term, and then integral dx is going to convert to x. So 3 times x is 3x, plus c2, which is a constant with respect to this part of the problem. Okay, so now we'll simplify this some more. X to the power of 1 plus 1 is x to the power of 2. In the denominator, we have 1 plus 1, which converts to 2, plus 3x, which is this part of the 3x, which I've written down next to this x squared plus 2, plus c1 plus c2. c1 is a constant of integration. c2 is also a constant of integration. So we can club these two constants into another constant c, and then write it out as shown here. So when we, in the next step, x squared plus x squared divided by 2 plus 3x plus c is our solution, where as we mentioned, as always, when we complete the integration process, we're always going to add a constant term to the solution, and c here happens to be a sum of a constant c1 and a constant c2, and then this is how we can use the sum rule of integration to solve simple example problems. Let's look at another example. Let's say we want to evaluate integral x cubed plus 7 dx. In here, we have integral x cubed plus 7 dx. So we're going to apply the sum rule, and then we're going to integrate. When we apply the sum rule, we can integrate each one of these separately, like integral x cubed dx is the first part, plus integral 7 dx is the second part. So, and when we complete the integration process, we can add the solutions together. So as we can see here, integral x cubed dx, this is in the power rule. We can use the power rule to simplify this part of the integral. And then integral 7x, 7 is a constant term, so we can use the constant rule of integration to simplify this part of the integral. So integral x cubed dx, when we use the power rule, it'll simplify as shown here, x to the power of 3 plus 1, the whole thing divided by 3 plus 1, plus c1. For this integral, we need to add a constant at the end of the solution, so that's this c1, plus integral 7 dx. Since 7 is a constant, we've taken it outside of the integration process, and then integral dx converts to x. So 7 times x is 7x, plus c2. c2 is the constant for this part of the integration process. So when we simplify this some more, x to the power of 3 plus 1 is x to the power of 4, since 3 plus 1 is 4. And in the denominator, we have 3 plus 1, which is equal to 4. So that whole thing simplifies to x to the power of 4 divided by 4 plus 7x plus c1 plus c2. So I've combined the constants to the end of the solution here. Since constant 1 is constant 1 plus constant 2, we can write it out as another constant c, and therefore I've simplified the solution as x to the power of 4 divided by 4 plus 7x plus c. So whenever, as I mentioned, whenever we complete the integration process, we're going to add a constant to the solution, which in this case happens to be c. In my next video presentation, we will be solving problems using the rules of integration.